Hello, in this video we're going to carry out a what's in my tray activity. You can see here that we've got our Gratnells tray. If I lift the lid you can see that we've got lots of BrightSparks for Kids components and resources. So in this activity we're going to challenge your circuitry skills and we're going to create a circuit with a run mode and a charge mode. So let's have a look at the components that we've got in our tray. We've got two capacitors, we've got two bulbs and holders, we've got a diode, we've got a two-way switch, we've got a hand crank generator, we've got a multimeter, and we've got 8 leads. Okay, so let's take out our insert and let's begin our activity. We're going to use our hand crank generator as our input. We're going to charge our capacitor. So you can see here that we have a circuit symbol for our capacitor and we have a black negative terminal and a red positive terminal. It's very important that we connect our capacitor the right way round and make sure that it has the right polarity, otherwise you can seriously damage your capacitor. On the side of your capacitor you'll notice that there are some negative minus symbols here, and that allows us to determine the terminals on our capacitor to make sure that they're mounted correctly. And you can see here that the negative symbol is towards the black negative terminal of our capacitor holder here. You'll also notice, if you look closely, that there are some numbers and letters on the side of our capacitor, and one of them with an F relates to the capacity of our capacitor, and that's measured in farads, and our capacitor is rated at 1 farad. It's also got a 5.5 volt capacity. Okay. Next we have a bulb. So we have our circuit symbol here, and you can see that we have two terminals. They're yellow, they're not red or black, and this means that we can put our bulb in either way in our circuit and it will still work. Then we have a two-way switch. You can see our circuit symbol here, and you can see one side of the switch we have one terminal socket, and the other side of the switch we have two. So that means if I flick the switch up, we'll be using this terminal here and the top terminal. If I flick the switch down, we'll now be using this bottom terminal socket and this terminal socket. So it allows us to run two branches of our circuit, and that allows us to have our charge mode and our run mode in our circuit. We're also going to use a diode. You can see the circuit symbol here. You can see that we have a black negative terminal and a red positive terminal. So once again, it's very important that we wire our component in correctly, making sure it's in the right polarity. We're also going to be using a multimeter. We're going to be measuring the voltage. So we're going to use the volts DC scale here, and we're going to use the 20 volt setting. You can see that we have 3 sockets. So one is marked COM, and one is marked volts, ohms and milliamps. So we're going to use those two sockets. So on our hand crank generator, I have a red plug and a black plug. So we're going to wire our circuit in so that I'm going to put the red plug into the red positive terminal of our diode, and I'm going to put the other lead into one of the terminals, this terminal here, of our bulb holder. Then I'm going to use a lead from the bulb holder here terminal to the second terminal of our two-way switch. I'm going to connect a lead from the black negative terminal of our diode into the second terminal of our two-way switch. Then I'm going to connect a lead from the red positive terminal of our capacitor, and that is going to go into our last remaining terminal socket in our two-way switch. Now I have to connect the bulb to the capacitor. So I'm going to put a plug here into this terminal of our bulb holder, and that is going to go into our black negative terminal of our capacitor. Okay. So if I put our switch onto the first socket here, it will mean that we are in charge mode, so we'll be charging up our capacitor. If I flick the switch, the capacitor should then be discharging, and that then should run our bulb. To measure our capacitor is charging, we need to use our multimeter. So we're going to use our multimeter as a voltmeter. Whenever you do that, you always put the voltmeter in parallel to the component that you're testing. So we're going to put a black lead into the COM socket of our multimeter and connect that to the black negative terminal of our capacitor. Then I'm going to connect a lead from the volts, ohms and milliamp socket of our multimeter to the red positive terminal of our capacitor. So now our circuit is complete. I'm going to turn our multimeter onto the 20 volts DC setting. And what we're going to do, we're going to charge our capacitor. We're going to spin our hand crank generator in a clockwise direction, and we're going to try to ensure that we have a 5 volt charge on our capacitor, between a 5 volt and 6 volt charge. So what I'm going to do, I'm going to start turning it, and now I'm going to count for 30 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so now our capacitor is charged. What we're going to do is we're going to throw our two-way switch so that our capacitor starts to discharge and then operates our bulb. We need to time that, so I'm going to use my phone, and it's already set on stopwatch mode. So I'm going to time it at the side here. Okay. So at the start here we have 4.29 volts charge on our capacitor. We're going to discharge our capacitor using our bulb and see how long our run time is. So if I flick the switch and start the stopwatch, you can see that the bulb is alight. We're coming up for 10 seconds and we have 2.01 volts. We're coming up for 20 seconds and we have 1.65 volts. We're coming up for 30 seconds and now we have 1.37 volts. We have coming up for 40 seconds, we have 1.12 volts. See, the bulb is just glowing. Coming up for 50 seconds and we have 0.9 volts. We're coming up for 60 seconds or a minute, just glowing, and we have 0.64 volts. I just about can see the bulb filament glow. So we have 70 seconds, 0.45 volts. And now the bulb has gone out. So we have been running for 1 minute 17 seconds. Now the capacitor will slowly discharge. We are currently at 0.12 volts. So we've been able to show that our bulb has a run time with around approximately a 4.5 volt charge on our capacitor for about 1 minute 15 seconds, mate. So what do you think would happen if we added an additional bulb to our circuit? If we incorporated a second bulb, but this time in parallel. So here's our second bulb. You can see the circuit symbol. And we're going to wire it in parallel to our existing bulb in our circuit. So I'm going to connect the red lead here to this terminal of our bulb holder and connect it to the first terminal in our second bulb holder. I'm going to connect the black lead here into the other terminal in our bulb holder, and connect it to the remaining terminal of our second bulb holder. So now our bulbs are running in parallel to each other. If I flick the switch, we can charge our capacitor again, making sure that we turn our hand crank generator in a clockwise direction. There's more load this time, so you can feel it's harder for me to turn. So we go for 30 seconds again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, we're going to need our stop clock again. Okay, so we have 3.9 volts on our capacitor. So if I throw the switch and start the stopwatch, you can see that we have both our bulbs alight. They're both running. But you can see the discharge rate is massive now. So with coming up to 20 seconds, I have 0.5 volts. And already our bulbs have gone out. So from a really high voltage capacity on our capacitor, it's discharged in a fraction of the time as it did do with our bulbs, or a single bulb in our circuit. We've managed to discharge our capacitor in under 25 seconds. Now, you notice that when I use the hand crank generator, I was always turning it in a clockwise direction, and that is because we've connected our circuit using our hand crank generator so that it would follow conventional current flow. We've also incorporated a diode into our circuit as a blocking diode to allow a longer run time for our components. Now, if I throw our switch into a charge mode and I turn our hand crank generator in an anti-clockwise direction, you see this time that we don't get a high charge rate, so it doesn't charge because we're operating our hand crank generator in the reverse polarity through our circuit. So some of our components won't operate correctly that way, and in fact if you do it too much and too fast with a hand crank generator, trying it on the capacitor can actually cause damage long term. So in our kit there was another capacitor. So where do you think you might put that in to our circuit, and what effect would that have?